So here's a more real-world type example, and we're actually going to do some more calculations with these in the future, but for now we're just going to focus on growth or decay and our y-intercept. So it says we put $1,000 into a college savings account for 4 years. The account pays 5% interest annually. It's growth or decay. What's my y-intercept? Okay, well, I'm getting 5% interest annually. So is my money going to be going up or down? Am I going to get more money over time or less money over time? I'm going to be getting more, so it's going to be growth. Now, what am I starting with? How much money am I starting with here? Well, I'm starting with $1,000, so there's my y-intercept. That's where it's going to be starting, and then over the 4 years it's going to grow. So, it's going to look something like this. And my y-intercept is going to be 0, 1,000. But it's a growth function, so it's going up and to the right. And I can tell, over time how much money I'm going to have. Each x value will be like a year. We're going to calculate some of that stuff here in the future. I know you're super excited. So we've got our exponential growth and decay function. Now you're going to want to write this down. I would write down all those little parts that are listed out there. So there's a common misconception with this part right here. Everyone thinks like a times t. If we plug a number in for t, it's a multiplication problem. We got to divide. No, this is strictly notation over here. This is saying the amount of whatever, let's say money in like the last case, the amount of money we have after a certain amount of time. That's what that is right there. It's just shorthand, math shorthand. This is where all the math happens, okay? This is our initial amount. So for that last problem, it would be 1,000. So over here we have our rate of growth or decay. And that's going to be pretty much given to us in a percentage that we need to change to a decimal. And we're going to add or subtract that from 1. That 1 basically keeps the original amount and then adds or subtracts whatever was gained or lost. It's kind of like if you were to calculate tax at a store and you were to say, okay, well, it's $10. If I multiply that by 0.0775 or whatever the tax rate is, I would get what the tax is. But if I did times 1.0775, I'd get what I'm actually going to owe the cashier. All right, and then T would be the number of time periods. A lot of times we'll be dealing with this in number of years. So here's how we're going to find our growth and decay factors. The exponential growth, we want to add, as I said. So if we have 12% growth, we add 0.12, so we get 1.12 for exponential. That's what would go inside the parentheses. Over here, if it's decay, well, now we have 0.93, so we had 7% decay, we subtract 0.07, boom. So let's find our rate of change, for each rate of change, let's find the growth or decay factor. So I'm either going to be adding or subtracting these percents written as a decimal from 1. So if I try that first one, I'm going to have 1 minus 0.09. Be very careful when you're writing these. It's not 0.9. That'd be 90%. So if I do that, I end up with 0.91. So that's what's going to be in the parentheses there in that formula. Why don't you guys try the next 3. Pause the video, see if you can get them. Hit play when you're ready, and the answers will pop up. Ready? Alrighty, and there we go. So we're adding for growth, we're subtracting for decay. Make sure you're very careful with converting your decimals to, your percents to decimals. Awesome. Now, you know what I could also ask you, because I'm crazy like that. I could say, like, here's our multiplier, our growth and decay factor, excuse me. What percent growth is it? And you'd have to say, well, it'd be 4.3%. You'd have to, like, work backwards. The tricky ones are things like the decay ones. You'd be like, okay, well, what's the growth or decay factor? You'd be like, well, it's decay, and it's by 9%. So you can work backwards the other way. Figure out what we subtracted to get there or what we added to get there. Those are fun questions right there.